The tool does is it will capture these, intersect them with the polygons of the buildings, and then calculate how much coverage there is per building. If it's fully covered, then it's destroyed. If it's minimal covered, then it's light damage, or that's the methodology I've used in there. And I can see this data here. Hello everyone, and welcome to this video. It's been a while since I've connected, been busy with work and life and but for now I'm back and I want to share with you an exciting yet sad workflow that I've been working on lately. It's always whenever a disaster takes place, I feel I have to really get something going, help however I can help from a geospatial perspective. And today I'm going to take you to Spokane in Washington. You might be aware of the wildfires that took place around a week ago, devastating wildfires that got tons of people displaced with damaged houses. And the least we can do is try to figure out how to size the damage. And we'd like to do it certainly, as this channel would suggest, GeoAI, utilizing GeoAI. So with no further ado, let's jump to my screen and see how to get to such results. We're looking at Spokane. Again, I'm using imagery courtesy of Nearmap in this use case. And we're looking at a fully automated workflow from feature extraction to classification to get damaged and non-damaged building. My best is I love shortcuts, so I'll go to feature layer and then swipe. And I need to select my map well. And I can see this data here. Again, this was a fully automated workflow. I'll take you through the process in a moment, but all what we had to do is really grab some images. And you can see this is the non-damaged area per se. And from the images, we need to extract some features and classify them as damaged or not. For this workflow, I'm going to use a tool that I've designed. I've shared it previously in a post on LinkedIn, but now I'll take you through downloading it and utilizing it and through the process of getting to such results. So what I'd like to do is jump to my Chrome. This is my GitHub repo. I'll drop a link for this in the description. There's a tool here called Damage Assessment under GeoAI Damage Assessment, which is a README file. All what you have to do is click on this guy and then download this file. And that's downloaded in my downloads. So I'll jump back to ArcGIS Pro, go to my catalog, and let's do this fresh. I'm going to do a new map, create a new map for this use case. I'm going to close my older maps out there. I'm going to look into my catalog and let's give it just a nice name, demo map. In this map, I'd like to use imagery. So I'm gonna just, having some location, I'll use the imagery hybrid base map. You might notice in the images, I have some GRP images coming from Nearmap. I've already created a mosaic data set for that. So I'm gonna add that to my layer and I'm gonna call it Nearmap Spokane images. I also know that there is an AOI for this image, which you'll see how helpful it is. You can always generate that, but well, the data came with it. So if I go into there, I'll have a survey file, and I believe that's my AOI. We can easily go and just get into an outline, and let's make it always like in these cases red. Close this message, it's gonna pop up out there for a while. So I've got this in. The next step for now is, so we've got images, we've got this guy. I'd also keep to working with catalog. Let me just spin everything down here. In the catalog, I wanna go where I have my database, which is here. And I wanna start fresh for this. So I wanna write all the outputs. I'm gonna show you the full workflow. So I'm just gonna create a fresh new database, call it demo database, and I'll make it my default because we're gonna save into it. So where is my default? Yeah, sometimes you miss these small things. Now that it is there, that's my default database. I do have a building feature, and I'll show you in the tool how to create that in case you need to do that. For now, I'm gonna grab that buildings feature, and it is actually this guy here. So if I add this to current map, I'm not gonna copy it to the database. You can see that I've got buildings, which will make my data a bit easier. This building feature was generated via a deep learning workflow, and we'll go through that. But you can see it's a building class, and that's all what it got down there. And we'll use it. Let's call it buildings. Then what I'd like to do to keep going, so I'm just gathering my inputs in here. I have my post imagery for the fire, which we got, and we can see that here. We can easily spot the damage. As we can do that, we'll see one workflow now where I'd like to create a feature class that shows where some of the damage happening. It's a point feature class, so I'll call it damage point, and let's just damage point, and I'll give it a point, and then next I'll leave this as default, nothing is needed. I'll keep this as default and finish. And all what you really want to do is go to edit, and then in edit create, and put some points where you see damage. I usually suggest 6 of these, so that's 1, 2, 3, and then I'm gonna start with the bare minimum really and just do 6. I think there was some damage in here also, so let's do 1, 2, 3. And in theory, these should overlap my buildings, which that's the case. The use of this, we'll get to it because we're actually going to be using embeddings for this workflow. And here's the surprise. I didn't mention it yet, but we'll get to that as we move. So we've got, I believe, most of what we need. Maybe make this a bit nicer for symbology purposes. Let's do Firefly, and I'll choose this red where you can easily see it, and then let's save and do this, and then map, explore, perfect. And it wouldn't hurt to really clear my selection, so I'll go ahead and do that. We'll know why in a moment. Next step, using the tool. I'm gonna go to my downloads, refresh the sky, and you can see that there's a download tool. I'll add it to my project. In projects, I'll go ahead and expand it. I'll trust this, and I can see automated damage assessment. So for this demo, I'm gonna skip this, which is really the most time-consuming workflow. You can either say, I have features to classify, which is actually how I got these in the previous workflow. I suggest you try this. These features are, you can choose them, or you can leave this as empty. And then this will use a pre-event feature extraction where you need input imagery from the pre-event. This could be any image. This is post-event really. So I've used that. I've got the buildings out there and then worked from them. In a lot of cases, you might find these features. I highly recommend you try this in case you don't have features. But in case you do, all you have to do is choose buildings and notice how these change. Buildings or any input feature. Also, you can do multiple workflows. I've tested with all of these to a certain extent and I've got pretty decent results. So I highly recommend testing that. For now, we'll stick with buildings. We've got that, and I've got an AOI, which I want to use, and that will clip my area of extent. That's my survey data, which if we zoom to it, we'll get in there. So I'm going to only process stuff within this, and you see my training samples are 6 points. These are where post-event imagery. I have input imagery. My post-event is Spokane. I have example of damage. That's the damage points. I'm going to use for this use case a Dino V3. These are fetched from ArcGIS Online / Living Atlas. Anything with embeddings will automatically show there. We'll also see custom embeddings model. If you want to add that, you can go and add your own DLPK. We'll leave that as default. I'll leave a batch size of 4. That's more than fine. There's an embedding grid size, which how much width by length do we need the box to be, which is usually a square really. So I think it will default to 5. You don't have to worry about it. I'll show you what these embeddings look like and what we're going to do in this workflow as I start running this. So I'll leave that as default. I'm going to say that I'd like points that are at least 65% similar to this damage point. So these are my samples, and anything that shows embeddings less, I don't want to use it. So I'm going to keep that. And then going on and forward, I need, if I have existing post-event embeddings, if you've already generated that, you can use it. Else, you can leave it empty. And then for the last step, the output, and let's call this Spokane Buildings Demo. And you see that's in my demo database. That's why we got a default. Now I'm going to up this a little bit. And what I'm trying to do here is, as I generate the embeddings, as I find similar damage embeddings, if my building overlaps 60% of these embeddings, then it's high damage, and else it will be classified accordingly. And I'm going to keep intermediate data for now. So from here onward, I have to run the process. Let's do that. And as this is running, I want to maybe show you a bit of these embeddings in the previous workflow that I've done. So we've got the damage, and you can see these here. I'll switch them on. And as I zoom onward, I'm going to add the embeddings. So I have a scale dependency on that. Maybe we can do this. So these are nothing but generated embeddings. If you open them, you'll see blob. You can export these through view fields. The tool to generate these embeddings, if we go to geoprocessing, as that one is running, and I'm gonna go here, let's clip it again, go to toolboxes and navigate to GeoAI. So all what I've done is really I've compiled these workflows together. I need to find the G, so that's GeoAI, and then you see embeddings based analysis. So you can first extract that last, first generate embeddings, and that's what will generate this grid. That's the grid size we specified or is automated in the workflow. You can open this tool and check it out. Input feature class or raster, whatever you want to generate embeddings for. Spokane imagery in this use case. Output feature class and the model definition, which you saw in the dropdown. Now these embeddings would look something similar to this. Where if I click on attribute, they've got a blob. If you use extract embeddings, you can extract these blobs into numbers that are really an index, an embeddings index. So you're not going to be able to understand these numbers, but it's what we're going to be used in the back end to find the similar polygons. The next step is, because we have the points selected, in this use case I had a bit more than 6, I think it was around 11, and we can see them around the area. These were the sample data. These, whatever intersects this, will be selected, and we're gonna generate similar to these. What that similar tool, which is this guy here, find similar features using embedding, would look like the red squares we have on the map. So for better visibility, let's zoom in a bit. And in theory, anything that is red is damaged. Anything that is not red is not damaged. Now, the next step, what the tool does is it will capture these, intersect them with the polygons of the buildings, and then calculate how much coverage there is per building. If it's fully covered, then it's destroyed. If it's minimal covered, then it's light damage, or that's the methodology I've used in there. So I hope with that, I've made it a bit easier of what is the theory I took or the workflow I took to get to a final product, and why I'm trying to save you all of that workflow. So if I close this for now, this is still running. Let's just to avoid adding any points. I can look into my analysis, look into my history, and then open this guy, which is running. Let's close these. And I believe it's gonna take maybe 15 minutes, 10 to 15 minutes. It's generating an area of 10 square kilometers of embeddings, and you can follow it. So user supplied target features for pre-event extraction is skipped. We don't need to worry about that. We've supplied the clipping extent, so I'm only going to use what's within the red area. We're using that much features, so we're classifying around 5,000 buildings in this workflow. Then we have 6 target. These are the points that we're going to find similar. An auto grid size, the 5x5 for buildings, which is relevant. You can manually change this in case you have a bigger buildings, go to 6, 7, 8. In case you have smaller informal settlements, maybe you want smaller embeddings. Your choice, also dictated by the resolution of the imagery you have for sure. It's using the ArcGIS embeddings model out of the box. I didn't have to download it. If you have it cached, it will pick it up. If not, it will download it on your behalf. It's reprojecting. I always like to work with WebMap, with WGS Auxiliary Sphere. In this use case, NAD 1983 will work. It's a projected system, but just to be safe, sometimes users use geographic systems, and I'd like to avoid that because with smaller features and working with degrees, you might. If you've tried it, you know what I'm talking about. And now it's really doing the main step, generating the embeddings. Once that is done, we're going to generate the similar or find the similar and then spatial join them and then get these out of the box. So I'll fast forward through this and we'll get back to you once the tool is done. And I'm back. So here we go. Keep an eye for this. It's relative image and evidence, not confirmed. A human in the loop is really essential here. We can't just rely on the methodology, but we're able to really detect high damage, moderate, and low damage evidence within our imagery. Now the temp data, remember we created a file geodatabase. Well, that was done for this whole reason of having these. That's what we manually created, the 6 points. We've got the post embeddings. We've got the buildings, AOI clipped to ours. We've got the similar embeddings and finally the classified buildings. So what I want to do, let's walk through these. These are our buildings. We can just remove this layer since we're done from it. We have our embeddings, which let's start with the post event embeddings. Also this AOI building can be removed. It's just a temp layer. These are all the embeddings and each one of these would look something similar to this as it's loading. It's just lots of polygons to load. So nothing super valuable here except till we add the find similar and we get these. And in theory, if we bring this under this, everything that is red should be damaged. So let's wait for that to load, zoom in into a little of the trick in here where actually, now let's leave the outline. So anything that is in red in theory is damaged. Let's double check. If we zoom here, we switch this guy off and indeed you see that in. The next step is overlaying these with the buildings and building counts. So we get these. The simplest way to do that is going to feature layer and then symbology. And then symbology will take unique symbols. And note there's multiple classes in there. The covered damage area, the building area. What we're interested in is the damage class. And you can see these are those out there. What I'd like to use is I know I've got a symbology somewhere with the colors that you've seen. So all I have to go is to somewhere in my folders, if I'm not mistaken. I might have been mistaken, so let's do it differently. I'll cancel this. And then the easiest, if I go to my catalog, I really like this trick in ArcGIS Pro. And then I open one of my old maps, which I started with. And then I copy. And then go back. right click, paste properties, and there we go. Fully automated with pretty decent results. What we can do is open this and maybe double check a little bit the counts of the charge. So we'll get in here. We've got damaged glass, got nothing selected. That's why I'm not seeing anything. So there's approximately 2,464 in my extent with no damage. That's the greens, moderate, high, and low. And you can check these all over the map. So again, in a couple of minutes, I think with a fully automated workflow, we can really see how far AI came in the geospatial world. It took 18 minutes if you have the buildings. If you don't, it might take an hour and a half to 2 hours to extract all the buildings first. But an end-to-end automated workflow. I really hope you've enjoyed this video. Subscribe, hit like if you want to see more, and please download the tool from GitHub and use it. I've tested this in different places around the planet and I've got pretty convincing results per se. So do that, classify damage, do more than buildings, and post in the comments any questions you've got. Thank you for now, and I really enjoyed showing you this. See you soon. Bye.